Hello everybody, welcome to Bill Sky, the C and C++ guy. And what we're going to look at today is we're going to look at how to access the computer's time and manipulate it and do things with it, get the data out, maybe convert some things. We'll see how it goes, but it's kind of curious how this is done. It actually uses, for C++, it actually uses the C code, or C code that's been around for many, many years. And I'm going to show you how to do both in C and C++, with a bunch of cut and pastes. We're going to do it in C++ first, and then I'll go ahead and create a C project, and you'll see just how amazingly easy it is on both languages. So let's get started. Okay, so I've got my, this time I'm using Alma Linux, and I'm going to go ahead and start a new project. Now this works the same if you're using MinGW on Windows, or if you're using Ubuntu, whatever the operating system is. I think it even might work on Mac. But I'm going to go to C projects, and I'm going to create a 64-bit application. I'm going to rename it. I'm just going to call it System Time. And let's go ahead and start coding. Now, one of the first things that you need to make this work is that you have to pound include the C time library. Now, to do this in C, now we're in C++ right now. To do this in C, you would simply say include time.h. But we're going to take a look at that later on when we actually look at a C program. Okay, so that's the first thing. You must have the C time header file set up. Now what we're going to do is we're going to create some variables that are going to hold the time. So I'm going to create a variable of the data type time_t, and we're going to call this the time. Now this will actually contain the time as a value. I believe it's in milliseconds from the clock inside of your computer. Now the other thing we're going to do is we're going to create a structure pointer of the TM type called time_struct. Now you can name this variable anything you want, but it's a pointer to a structure of the type TM. And I'm going to show you how to get to that. Actually, let's do that right now. So what I'm going to do is I'm going to go ahead and load up my browser, and I'm going to go to c++.com, and from within this really great reference, I'm just going to do a search for C time. And here you go. So here's your C time, and let's take a look at some of the things that we have here. It really tells you a lot of stuff that you can do here. Basically, it just tells you everything if we can get rid of these advertisements. Okay, so everything you need is here. They talk about the different functions. They talk about how you can dissect it. It also says, take a look at this, take a look at time. So really a great reference to learn how to do this. But we're going to go ahead and we're going to just start doing some code here. So this is the actual value of the time, and this is a time structure which will actually convert that into real data that you can use. Okay, so let's go ahead and do something very, very simple. So there are going to be some more variables we're going to do. So I'm going to say, hey, time, I want you to call the time function, which is part of C time, and I'm going to give you the address of the variable, the time. So I'm going to send an ampersand the time. And then I'm just going to say, I don't know, let's go ahead now and take that data, and I'm going to just say count the time, just so we can see it. And let's save and build this. Again, you could do this in Visual Studio Code if you like. I like doing it on Linux. And I'm going to run it. Okay, so you can see this really big number. And that's really not a number that we want to use. Now if I run this again, you notice the number has changed its value. It's gone up by 8. That's 8 seconds. It's now gone up 5, 2, 1, 1. So you can see that is the number of seconds since January 1st, 1970, I believe. That is the most computers' time epoch, the epoch time. Okay, but we want to do something more with it. So what I'm going to do is I'm going to say time structure. So I'm going to say my time structure is equal to the Greenwich Mean Time. I was getting that wrong. So what this is going to do is it's going to say, it's going to run the Greenwich Mean Time, the GM time function. We're going to send it the time, and it's going to put that data inside of the time structure. And we're going to take a look at that in just a little while. And then I could say count time struct. Let's build that. Let's run it. Okay, and we got the address for the time structure. We didn't actually, we could have dereferenced it by putting an asterisk there, but you really don't want to use the structure that way. So what I'm going to do is I'm going to count the current date and time is, and I'm going to run the function, or call the function ASCII time, and I'm going to send time struct. And let's get to that terminal quickly. All right, this is much more usable. So the current date and time is Tuesday, January 18th at 1941:51, 2024. Now, notice that really isn't the time. Let me take a look at my clock. What's my clock say it is right now? Right now it's 12:42. So, but that is the time. 1941 is the Greenwich Mean Time, which is a time in the UK, the United Kingdom, that is basically 0 hour. And I would like to actually see that as local time. So what I'm going to do is I'm going to say time struct equals local time. That's another function. And I'm going to send the time structure. And let's say the current local date and time. So let's go ahead and save and build that. Go to terminal, run it, and you can see that now we're looking at, well, kind of close. It says it's 1442. We're off a little bit. We're going to take a look at why that is, but it shows that it's June 18th at 1442. Now, this is actually 2 hours off, and the reason for that is that my Linux stores time a little bit different. So these are all things that you have to worry about. And we're going to see what that is in just a moment. So you want to make sure that your Linux, and I'm in a VirtualBox, actually I'm in a VMware guest operating system, so I don't remember if I set this up to get the time from the local host computer or if it's getting it on its own. But you can see there is a difference here. Instead of 1942, it's 1442. And I believe this might be East Coast time right here. Is that East Coast time, 12? Nope, that's Central time. So anyway, we'll get to it. We'll figure it out. Okay. So the next thing I'd like to do is I'd like to take that structure and separate it out, because this is just ASCII time, ASCII time, just prints out this really nice, Tuesday, June 18th at that time and then the year. But I would like to take every one of those pieces of data out one at a time separately and do something with them. So maybe, my time, my time, I'm having a senior moment here. My time zone, there we go. My time zone is different, so I might want to do some math on that, and we can actually do that. I know that this is 2 hours off, so I maybe subtract 2 from that. So let's start playing with that. Now, before we do that, we have to create some local variables to hold that data. So all of the variables that come in that TM structure, they're integers. So I'm going to say integer the seconds. I'm going to say integer the minutes. I'm going to say integer the hours. So let's just go with that right now. And what I'm going to do is I'm going to fill those in. So I'm going to say the seconds equals time struct, and it's TM underscore sec. Now we put the dash greater than there because this is a pointer. The time struct is a pointer. So we want to put that dash greater than there. And some integrated development environments like Eclipse will do that for you. Okay, so that's the seconds. I'm going to say the minutes equals time struct TM min. The hours equals time struct the hour. TM hour. Let's save and build that. Okay, it says that I really haven't done anything with this, so those are just warnings. So let's go ahead and print out our time. So I'm going to say count. I'm going to call this one current dissected time is the seconds, the minutes, and actually shouldn't it be hours, minutes, seconds? So let's change that to the hours, the minutes, and the seconds. All right, let's go ahead and build that. All right, looks good. Let's go back to terminal. And there you go. So 14, 46, 33, and I can run this and I can see the seconds moving up. Pretty neat. So you're able to actually grab that data, one piece of data at a time from the structure. And then you can also manipulate that data. I wouldn't manipulate it in the structure. I mean, you could, I guess, but I like to manipulate it inside of the variables. So let's go grab the rest of that data. So let's grab the year. So I'm going to say, oh, I don't have the year yet, so let's create the year. Let's create the month. Okay, so the year, the month, and the day. All right, and let's grab that out, that data. The year equals time struct, TM year. And let's just go ahead and say count the year is. And let's save and build that. Oh, what did I do here? TM. Oh, I didn't do that right. I need to put the structure. Time struct. All right, good. The compiler told me I messed up. Okay, the year is 124. How can isn't it 2014 or 2024? Well, the reason is because the year is the number of years since 1900. That's just the way they decided to do it in this. So if I actually want to print the real year, I would add 1900. Now, I'm not sure why I did it that way, but we can go ahead and fix it. And there we go, 2024. Again, I'm not sure why I did it this way, because I did grab the year up here. So probably what I could have done is just said the year plus 1900. I could have also modified the year directly. So I could have said the year plus equals 1900. And then just said the year. And there it is, 2024. So, you know, there's a little caveats here, but they're very easy to overcome. All right, so let's go ahead and grab the month. So I'm going to go and say the month equals, and I believe it's TMMON. And I like doing these things one at a time, just in case something isn't what I thought it was, and it makes it very, very easy to find the error. Okay, good. So let's go ahead and I should have said time struct. And it said the month of 5. Well, wait a minute. It's June. I know that for a fact. We can see right here it's June. Why did it say 5? Because it's the number of months since January, not including January. So really what we have to do here is that we have to say the month plus equals 1. So we have to add 1 if we want to do that. It's like it's January, the month is 0. Okay, a little bit confusing, but you know, you try these things out, and there we go, the month is 6. Now, it would be nice if it said June, so I wonder what ASCII time does. ASCII time probably has a switch statement in there. So switch the month, and let's go ahead and create a little string up here. I'm going to say string, month string. And then I'm going to say case 1 string equals January. I think you guys are getting it. I always like to have an open and close, and we're going to break. I got 12 there. And let's change that to 2, 3, 4, 5, 6. Whoops. 7, 8, 9, 10, 11, and 12. Now let's save and build this. Okay, good. Now one thing we don't have is that we don't have the default. So I'm going to say month string equals system error. Something happened. The function to get the current local time returned something really weird. So we're going to go ahead and just put system error there. Okay, so let's make this February, March, April, May, June. Now, if you know how to do this, if you know where I'm going with this, go ahead and fast forward. But it's good practice. I haven't coded in C++ for a while, so this is nice practice. All right. Let's build it. Seems to work. So you could create a little function to do that, to send the actual integer to a function that says, I don't know, month to string or something like that. And you can grab it that way. Okay, so we got the month. Let's go ahead and get the day. Now, did I create a day? Yep, the month and the month, the day, and the year. So we got the year, we got the month. Let's get the day. The day equals, and I believe it is time struct PM month day. What does that mean? So let's count it. And let's see what we get. All right, it's the 18th. Is it actually the 18th? Yes. I don't know why they didn't start the first day as 0 like they did the months, but the first day is 1, so this is the day of the month. And it seems to have started with 1, so that's pretty cool. So that's the day of the month. You could have maybe called this the day, the month day, or the day of the month, something like that. Now, one thing else you can do is that you can do a check for daylight savings time. So what I'm going to do is I'm going to create a function called, well, not a function, a variable, but let's not do that. So I'm going to say cout daylight savings flag is time struct PM is daylight savings time. And I believe it's a Boolean. So let's just go ahead and make that. Let's go back and run it. Okay, so daylight saving, now it is June, it is daylight savings time in the United States, So that would be a 1. So what you could do is you could say if time struct is DST, so if it is daylight savings time, now you spring forward, right? So in the spring you forward, so I'm going to say the hour plus plus. And also I'm not going to do anything. I'm just going to leave it alone. I'm going to say C out. And let's save and build it. And let's run it. Oh, what did I do? Oh, it wasn't the hour. So let's see if I got this right. So time struct. Oh, TM underscore DST. There we go. And let's make sure I got my hour, the hours. So there's an S at the end, which probably wasn't a good variable name. Let's save and build that. And there we go. So the hour adjusted for daylight savings time is 1500. So there's something with my Linux. If I take a look at the Linux up here, it does show 1457. So there's something going on with my Linux. It shows us 1457. I'm not sure. Sometimes the guest operating system's time can be messed up a little bit. Maybe not messed up, but not just adjusted to match the time of the host. Because right now my host computer is at 1257. So maybe I need to go in here and make some changes. But I'm sure. But that's how you can do it. Now, how do you do this in C? We did it in C++. Let's do it in C. You're going to be amazed at how easy this is. So what I'm going to do is I'm going to minimize. Let's get rid of all of these other programs that I was editing inside of my Genie editor. And I'm going to go ahead and I'm going to create a C project. And let's do it in 64-bit. And I'm going to call this one System Time. And let's edit it. And where's my Genie? There's my Genie right there. And there's my C, my main.c. Now I'm going to go up here. And instead of saying C time, I'm going to say pound include time.h. That, along with the C outs, that's the only changes that you have to make in this code. It's actually pretty neat. I'm going to go in here and I'm going to copy. Well, we can't really do it with month string either. So let's go ahead and copy, because there is no string. It's a C string. But we can do that. We can handle that. So there we go. So now what I'm going to do is I'm going to say char. So instead of month string, I'm going to say char month string. And let's make this, I don't know, 18? I don't think the month names are that long. But let's go ahead and make, say, month string. And then what I'm going to do is I'm just going to copy all of this code that I did in C++. I'm just going to copy it over main.c. It might have actually been easier if we had done this in C to begin with. But let's go ahead and copy that into main.c. There we go. And everything is the same except for the C outs. So for the C outs, we want to change that. Now, if you haven't looked at my printf video on C, take a look at that. It'll make complete sense. So I'm going to say printf, and I'm going to say %d \n, and instead of less than, we're going to say comma, and that's pretty much it. So let's go ahead and change all those. Now I'm going to go ahead and try to make this a little bit faster. I'm just changing all of my C outs or couts or whatever you want to call it. I'm changing them all to printfs. We're saying that I'm going to print an integer and a new line, and everything else stays exactly the same. Well, this one's a little bit different, so we'll say hour, minutes, seconds, and we'll say the hours. And we don't want to print that. the minutes, the seconds. Okay, that should work. Now let's do the year. Again, if you know what I'm doing, if you don't want to have to watch me do this, go ahead and just fast forward. But this is good practice. I just did this last night getting ready for this video, and I'm still going to do it all because it's good coding practice. Okay. Now, the other problem is that month string is no longer a string, so I'm going to say strcpy month string January. strcpy month string February. I like a space at the in between. Let's do a little bit of copying and pasting here. I probably could do a find and replace. I got my close parenthesis. This is a lot faster. I think that should be it. Yep, that's it. Oh, nope, forgot May. Let's get May done. Again, if you notice, the time thing isn't what's holding this up here. It's the strings, because there are no strings in C. Okay, so now we want to do another printf here. We're almost done, I promise. I just think we got a couple more. Oh, I forgot the format commands up here, or the format string. So let's put our %d \n, %d \n. Still not done. I actually don't like doing this much coding without building it, but you know, I've done this before. And here, let's do our print. This is our last one. Printf. Now this time, instead of %d, we're going to say %s, and then \n. Oh no, that's a %d. That was, oh, that was the month up here. If I remember right, yeah, that's a %d. I don't want to do that. I believe it's a %s. Now, I'd be amazed if this compiled the first time. Drum roll, please. Oh my goodness, so many different things. So let's see. Okay, we forgot to do this one. So printf. Okay, I don't think that was the only one, but let's take a look. Oh. All right, still have, oh my goodness, implicit declaration of strcpy within C. So let's go ahead and to use strcpy as the pound include string.h. Okay, and instead of, you can't just assign a C string to a C string, you have to say strcpy. All right, let's save that and build it. There we go. Now let's go to terminal. And it almost worked. Segmentation fault, core dumped. Oh my goodness. What in the world happened? So let's take a look. If we did anything funny, char month string. Let's do this. I'm going to say printf begin, you're here. Okay, it said you're here, but I believe it was this right here. So let's figure out what's going on there. Okay, so let's move this right there to see if it's this one that's causing me the problem, and I believe that's what it is. And, well, no, I said print here. Oh, you know what it is? It's this right here. I'm trying to print a string when actually the time is just a big number. I could have debugged it probably, but let's go ahead and see by changing that %s to a %d. Okay, works great now. So it's pretty important. Now, this, yeah, we've got some problems here though. So welcome to C. Let's see, time up. So we said print f the time. So the current date and time. Yeah, we've got a little bit of an issue here. Not sure what's going on. Probably because this should be an S. Yep, I got my formats wrong. Let's make those strings. There we go. So the current date and time is this. The local date and time. Everything else looks pretty good. There's the time that you see right there. Yep, that's it. 2024, 6 June, 18. All right, looks great. So that's in C. And really, what did we change? We changed it from a C time on the pound include to time.h. We had to include string.h due to the strcpy. All the variables are the same except for the month string. We made that a char. And all the couts we had to change to printfs. That's what caused us the most trouble. Then we had to say strcpy to copy the C string into the variable month string, but it all seemed to work out. And so it's just those simple things. But the whole thing with time was pretty much the same. All right, so that is accessing the time. That's accessing the date. You can go ahead and play around with that. Once you get the data into your own variables, you can do anything you want. You can ask the user, what time zone are you in? And then you can change the hour based on that time zone. You can even ask them, do you want to revoke or initiate the daylight savings time? All kinds of things that you can do. Now, I didn't show you how to actually modify the system time in your computer because you should really leave that to time servers. That's probably the reason why I'm having a little bit of a problem here with my Linux, because I don't have the time set up correctly in the operating system. And I've really never tried that with Alma Linux. I'm not really sure what's going on there. I'll figure it out. Maybe I'll put some comments or what I did to fix that inside of the description of this video. So that's time, that's dates in C and C++. Hope to see you at our next video.